What's up, guys? Van here with your next Java 2D game engine development tutorial. This one's been a long overdue, and I'm sorry about that. I've been in recovery from wisdom teeth surgery. I had got all four of them removed, and I'm feeling up to making a video today. I still got holes in my mouth and stuff like that, but we'll make do with it. So today what we're going to be doing is we're going to be doing entities. Yay! We're going to be creating the basic player. So last time what we did was we did the levels and the tiles and stuff like that within the level. And this is what we came up with it. If we just run it, make sure everything's how I remember, which it is, good. So we move left and right and up and down. And it won't move until we pass that center point here, but that's just for now. So we're going to be translating that into an actual player class today. So let's get right into it first off. So first, we are going to need to start off with a new package here. So we'll create that right now. This is going to, let's just create it inside this package here. So click there and click there. And then we're just going to call it .entities. Entities, yep. This entity class is going to be an abstract class. Now, we'll make the class right now. Oops, should be calling it entity, not entities. My bad there. Let's just rename that there. Okay, entity, there. So this is going to be an abstract class, and I'm not sure if I've described abstract classes before. I think I tried recording this before I went on my surgery, but I'm not sure. But essentially an abstract class is kind of like a blueprint for classes, so we can base this class off of, or we can base other classes off this class, and they'll have the same methods and variables in it. So instead of having an XYZ for every single mob, we can just put one in the entity class here, and it'll automatically be in every mob if we extend this class. So we make it an abstract class by right up here where it says public class, just write abstract and put a space. That makes it an abstract class. Now we just put the regular things that will be shared, so the blueprint things. So we're going to need an x and a y coordinate. We'll take a level, protected level. Oops. Now we'll just set up the level. So public entity. So this is the constructor, and import level as well, right there. Take in a level. And then this dot level equals level. Actually, let's put this in a final variable. We're just going to make this final so that it runs once. So public final void init level. This dot level equals level. Oops. Equals level. Fingers may be a little slow and sloppy today, as I haven't been doing much typing today, or the past couple of weeks. But yeah, then you just call this initialize function from your entity class, and that will run once this class is created once. Now we need a couple of functions in here because we want entities to do things. So we have our data members because that's all we really need for now. We can add more stuff later on. We'll make a mob class which extends this because this will be just a generic entity which appears on the board. But entities will also need to tick. So what we're going to do is we want this class to be overridden. We don't want to actually give any definition to this class here because we don't know what it's doing. We just want to say that it will exist, and that should be level. We just want to say that it does exist and that these will exist in subclasses. So we're going to need a tick function, and then you just end it with a semicolon, just like the variables here, and that'll say that this class needs to have this method in it. We're also going to need a render method. Void render, and that'll just take the screen because it won't need the x and y coordinates or the x and y offset as we've done before because those are actually located right here. So yeah, there's that. Next, what we're going to do is we're going to work on a mob class. So this will be a basic class that's extended by all moving not player entities, but all moving entities that are mobs essentially. So we'll just call it mob. Thought I hit my caps lock there for a sec. Okay, so this is just going to be a generic mob here. Sorry about that. Grandmother came in. But so what we're going to need to do is it's going to need to have all the variables and such that were in here as well. But this is also going to be an abstract class because we don't just want to have one mob. We want to have mobs extended by this class. So this class will have some abstract. This abstract class will have some definition to it, such as functions like a move function, kind of like stuff like that. That'll be shared across all entities. Or all mobs, sorry, but we still want it to be abstract because there are some things here that we still want to do, like the render class. We don't want to say how a mob is rendered in the mob class. We want to say that in the actual definition of the mob, like the player. So we're also going to extends, oops, extends entity. Now what that's doing right now is we're going to import it, and you'll see this pop up here. But this is essentially saying that we're going to be using this class as our blueprint. That's all that really is saying. So now we go here. It's going to ask us for the same constructor that's in here. Okay? And in that constructor, it's going to use this keyword super. Now what the super means is the super is going to call the class that's the blueprint. It's going to call one level up. So the super of this class is entity. So it goes into this. That's all that really does. Mobs are also going to need a couple variables in them as well, so we're going to add those right here. We'll want it to have a name for what kind of type of mob it is, kind of like if it's a player, if it's a zombie, etc., etc. We'll set the coordinates here, and we'll give it a speed. Why not? And then we'll need to add those variables here. So actually, we'll make these protected. That's what I should have done with this. Actually, no, I did. What a protected class is, I didn't go over protected, what that keyword is. What it means is that this variable level will not be able to be seen by any class other than classes that inherit entity here. So if we were in game, for example, and we have an entity, like, I don't know, let's just make it right here. We had some sort of entity, ent equals, and we'll just set it to null for now. And then if we did ent dot, we would be able to see x and y, but you'll see here that we do not see we don't see level because level's protected. Only subclasses can see that kind of thing. So we'll just backspace that. So that's essentially what protected means. And we want everything to really be protected. We want to keep as many private variables as possible because that means that other people can't get into the code and access things where they shouldn't be. So we're going to do protected string name for the name of the mob, protected int speed, protected int num steps. This will be how many steps the mob's taken. So it'll be a number, I don't know, divisible by a billion. It can be infinite, however far they've walked. That's what that is. Protected. We'll have a boolean here for if they're moving. Is moving. We'll have a protected int. This is going to be a moving dir, and we're going to set that to 1. Now what this is going to mean is this is going to be whatever direction that the mob is actually moving in. We could have variables for saying is moving up, is moving down, is moving left, is moving right. That's a lot of maintenance, so we're just going to include in this one variable, and we're going to say 0 is up this way, so towards the top, so they're facing away from us. 1 is down, so they're walking down. 2 is going to be left, and 3 is going to be right. We'll do that. So 1 is just means that they're facing the camera essentially. And we'll just have a scale. I think I did the scale in the other one. Yeah, I did. So there's that. Here we got to set all this. So this dot name is equal to name. This dot speed is dot speed is equal to speed. This dot x is equal to x. Oops. This dot y is equal to y. Oops, y. Okay. So there's all that. So that sets all these variables up here. Now what we need is our move function. Now this function is going to get a little, not too complicated, but it'll be up there. So it's going to be move. It's going to be a void method. It's not going to return anything. And in the method, we're going to take an int, an xa, and an int, and a ya. And what these two variables are is they're however many we're moving in a certain direction. So if xa is 1, we're moving 1 down, or we're moving 1 left. Wait, right. We're moving 1 right. Sorry about that. If xa is 1, we're moving 1 this way. If xa is -1, we're moving 1 that way. If xa is 0, we're staying still in the x. If y is negative, we go up. If y is positive, we go down, etc., etc. So that's what those are. Now we want to check if they're not 0. So we only want to be moving in one direction at a time. We don't want to move diagonally, because then people can if you get a 1 and 1 here, they're going to move 2 blocks, kind of. So instead of just going 1 over or 1 down, they'd essentially be going 2, and they'd be going twice as fast. And we don't want that. So if xa is not equal to 0, and, 0, not equal to 0, and ya is not equal to 0, so if both these variables are some denominator of a number that aren't 0, so if they're moving in both directions, we're just going to move in separate directions at a time. So I'm going to say move xa and 0, and then move ya and 0. Now what that's going to do is it's going to move one direction and then the other. It's not going to do both. And then we're also going to decrement num steps. I'll explain that a little further, and we're going to return, because we don't want to keep going in this method here. What we're decrementing here is because if you're moving, this is going to count it kind of twice. because we're moving in one direction, we're moving in the other. So it count that move as 2 moves, when in actuality it's only actually 1. So that's why we're decrementing it there, just to keep it accurate. Here's where we're going to add to it. So we're going to plus plus because we're saying you're taking a step. Now we're going to have a function which we're going to create, and we'll create that in a sec. And if has not collided, so if you have has collided XA, YA, and this function is just going to be if you hit a block, this is going to be our collision detection. We'll probably do that in 2 episodes. Next episode we'll do the walking animation, but which is actually really simple. But yeah, so we'll get to that in 2 episodes. What this is, we're just going to return true on this method, or false, sorry, so you can really walk anywhere. And then we're going to say if YA is less than 0, then the moving direction is going to be going north, so we're going up. So we're going to say moving dir is equal to 0. Okay? Now, if YA is greater than 0, so if we're moving down now, moving dir is equal to 1. So this is just going to be setting all these variables. If XA is less than 0, moving dir is equal to 2. If XA is greater than 0, moving dir is equal to 3. Okay? So those are their directional, or north, south, east, west, if you will. Now what we're going to do here is we're going to do x plus equals XA times speed. And y plus equals YA times speed. That's going to move us all around. Next, what we're going to need is we're going to need this has collided function. Now, we don't want to actually define this function in this class because mobs can be different sizes. We can have a 16-pixel player, we can have a 32-pixel big giant, we can have whatever. So we don't want this collision detection to be native to the mob class. We want it to be native to the actual entity, the actual mob that we're talking about. So that's what our abstract class is going to be. So it's going to be public abstract again, boolean, and it's going to be has collided, and int XA, int YA. And we're going to semicolon it again. Next, we're just going to have a basic method to return the name. So get name, return name. Okay. And that's, I think, so that's it for the mob class now. Next, we're going to be moving on to the player class. So this is the final class that we're going to be doing. Then we're going to be editing and drawing some things. So we're going to create a new class here, and we're going to call it player. And player, now that mob extends entity, we're going to just extend mob here, because a player is a mob. It's going to pop up this error, so we're going to add a constructor. We're going to remove this to-do. So now we have the level. The name we are not going to include here. We'll include the x and the y, and the speed will be native to the player as well. So we're not going to allow people to set that otherwise. That's all we need. We will also need an input handler, actually, because we want our input. Remember in our game class how last time, right here, how we had this x and y, and that's how we moved across the screen, and that's how we did this? We're going to move that into the player. So we're going to have input handler, input here. And then we're going to have private, because nothing else needs to see the input handler. Input handler, input. And we'll include a color for the player. We'll do that after, actually. We'll do the color after. So input handler speed is going to be 1. We just want them to be walking at 1 for now. And the name is going to be player, just for now. So there's that. Now this is going to pop up because we don't have our implemented methods. It's nice we've implemented them. We have has collided here. We have tick, which was from entity, and render, which is from entity. We don't need these override syntax. They don't really do anything. It's just so that you can see that it's overridden, but you can also see it from this little thing here. And I just realized I don't have line numbers on. Sorry about that. I'm not sure if you needed them or not, but yeah. Anyways, back to the constructor. So we need to set input now. So we're going to say this.input is equal to input, just to set that variable up. Has collided. We'll do something with this in a sec. I'm going to move this function down, actually, because I just want it down there. We'll do something in a sec so you can't go off the screen, because you'll see that. But anyways, so let's do the tick function. So tick, we're going to have an int xa is equal to 0, int ya is equal to 0. If input, actually let's just copy that. let's go into the game class. And now, okay, there's an issue that I've been finding. A lot of people who have been having issues and have been messaging me about their issues haven't really been about syntax and haven't been about them not understanding things. It's about copying things incorrectly. So when you copy things, make sure that you're copying and changing variables correctly. Like some people are not changing certain y variables that should be changed to x, and certain x variables that should be changed to y, etc., etc. So make sure you're doing that kind of stuff because you really need to be doing that. So anyways, let's just copy this here because we don't need it. We'll leave everything else, and we'll remove those variables in a second. And instead of y, we're going to say ya, xa, xa. Just because we want to update these variables, not the actual move variable, like the actual place that you're at yet. Now we're going to say if xa is not equal to 0, oops, or ya is not equal to 0. So if we're moving in some direction, we're going to move. And we're going to move xa, ya. Okay, and then is moving equals true. Else here, we're going to say is moving equal false. We could include this moving variable in the move function, but I'm just going to put it here for now. We might change that later. So yeah, that's the tick function. This will get you moving across the screen and such. So we can go ahead and remove these, which will spit out warnings for this. We'll fix that in a minute as well. Don't worry about that. Let's go back to the player class and let's deal with the render function. First off, to deal with the render function, we're going to need some sort of character. So we're going to do that right now. This is our sprite sheet as we last saw it. I haven't done anything extra to it, except this looks like it's a gray down here, which it is. That should not be a gray, that should be a black. Black. There. Not sure why that was. But, so we're going to make the player right at the bottom here. We don't want to take up any of this area, just in case we want to put something there. We can always change these numbers later on, but we're just going to put him at the bottom because we don't want to take up any space anywhere else. I'm going to make him 16 pixels by 16 pixels. We could make him 8 by 8 and then scale him up a bit, but it's probably more performance better, and you get a little bit more room to be a bit more free. So I'm going to draw something basic. My skills are not in pixel art, so do not expect this to be some incredible pixel art animation guy. But we're just going to put him in here for now. I'll probably... Actually, yeah, I'm going to do this... Oops. That's not what I meant to do. That's what I meant to do. We'll put him in here. We'll have black as the background color, so the black will be a transparent color. And then we'll have 3 colors for the player. We'll use the white for his face and kind of color, hands color and stuff. We'll use the dark gray for an outline of him, and the light gray for kind of like some of the inner features, like a shirt and some colored things. So I'm going to draw a basic sprite, and then we will be back in a second. Okay, so now we got a cute little guy. I think he's alright. We got a black background, a border around him, nice white. I don't know. I'm not the greatest at this kind of stuff. So, save it. Yes. And let's go into Eclipse. And let's refresh our workspace here. Okie dokie. Now let's do our render function. So, I believe that he is 28. At this tile right here, I think it's 28. Yeah, because this is 30, 31. Yeah, so that should be 28 and 0. So let's just write these tiles down. So int x tile equals 0, int y tile equals 28. So that's where he is, where the first tile of him is at least. Now we're going to need to render him. So let's go back and look at the screen class. Now, I thought I did this last time, but apparently I didn't. And I might have not done it. This is what I might have been planning to do, but I didn't do. These we're going to change into one variable because I don't want to keep going back and and looking at these variables. I don't want to have to go back and add true and false and true, etc., there. So we're going to change those. Actually, why not? Why don't we do that right now? So what we're going to do is we're going to have 2 bits. So we're going to use bits. I talked about this before for one variable. But essentially, if we get a 0, 0, it'll be normal. If we get a 0, 1, it'll be flipped along the x. And if we get a 0, 2, it'll be flipped along the y. I think that's what we're going to do. Yeah. So let's just create those variables up here so that we know what's what. So public static final byte. We're going to use bytes because we don't need anything bigger than a byte for this. Bit mirror x. And this is going to be equal to 0x01. So it's just equal to 1, okay, essentially. Now bit mirror y, and this is going to be a 2. Okay, simple as that. Now we're going to come down here. We're going to change this, and this is going to accept one. Let's accept. Do we want an int? Yeah, let's take an int. So we'll say int mirror dir for mirror direction. And then we still have these variables here screwing up, so we're going to say boolean mirror x, boolean mirror, mirror y, and equal to nothing for now. Now the mirror x, what that's going to be is it's going to be simple. We're going to use bit masking again, like we did, or bit mapping again, like we did earlier. So logical operators here. So we're going to say mirror dir, so this direction, and bit mirror, and oh, my key got stuck there. Mirror x, if that's greater than 0. So if this and this are greater than 0, then this is going to be true. If this and this are not greater than 0, so if it's a 0 because this doesn't exist, because if you take a 1 and a 0, you're going to get 0. If you take a 1 and a 1, you're going to get a 1. So if a 1 is sent in here, that's what that's going to be. Next, what we're going to do is here, we're going to say mirror dir and bit mirror y. Y is greater than 0. Same kind of thing. And that'll mirror it on that axis. The render function here, we can just take that out and send it to 0. 0x00. Just to be thorough. So there's that now. I don't think anything else really breaks because of that. Nope. So that's good. So let's go back to the player class now. So what we're going to do is we're going to render the player. So we're just going to render each. We could make a sprite class and then just render the sprite. But we're just going to render each tile individually because if we want to do something like water effects, we'll just cut him right here. And then he'll just look like he's swimming because he won't have a body. Stuff like that. So that's what we're going to do. So we're going to do screen dot render. The x position is going to be, okay, so we need some offsets here because we need to offset this player. If we just render every player where exactly he is, this will be like an x and a y, then it's just going to be every square on top of one another. So we're going to need some offset variables here. So we're going to have a modifier variable, which is essentially going to be the size of it. So if it's an 8, if he's at 8 by 8, then he's going to be an 8 by 8. Like if this tile is 8 by 8, then he's going to be an 8 by 8. If this is a 6, if we want him to be 2 times the scale, so he'll be 16 by, like this tile will be 16 by 16, then we'll do that instead. So we're just, that's all this variable is going to be. So we're going to say 8 times scale. We haven't done the scale yet. I'll do that next video. I'm sorry about that. I thought that I did that earlier, but I guess I didn't. So just don't worry about scaling them up for now. The actual algorithm we'll go over next episode. I already have that worked out and stuff. So I thought we did it, but that's okay for now. Next we're going to need an x offset. Sorry about that. What this is going to be is it's going to be an x, the actual x coordinate, minus the modifier divided by 2. Because we want to get it in the center. So it's going to be, yeah, that. Next we're going to need a y offset as well. So that's going to be y minus modifier divided by 2. Then we're going to minus 4, and we're going to minus 4 so that the waist of the player is actually the center of the y instead of the middle of where the 4 images meet. So next what we're going to do is right here, screen.render, we are going to have this 4 times. Actually, I'll just copy it after I do it once. We're going to have it 4 times though. So we're going to say x position is going to be x offset plus modifier, okay, and modifier, sorry. The y is going to be y offset, just a regular y offset. The tile is going to be x tile plus y tile times 32. We did this before so that you get the actual tile number. There's going to need a color, so we'll make a color variable up here, which I did earlier. We're just going to set this to colors dot get, and now this colors we'll do, I don't know, a negative. We need a -1 for the black background. I'm just looking at the sprite on my other screen here. We'll have kind of like a dark gray. Yeah, dark gray for the outline of him. We'll have kind of a cyan color, it's kind of a cyan teal color. So that should be. And just regular skin color. That should be that. That should look too bad. We might have to alter that later on, but that's completely fine for now. So there's that tile. So we'll put in color. And then we need, if we're flipping it, and we're not. So we can just do that. I think that's correct. Yes, that's valid. I think we can actually remove this for now. Oops. Yeah, let's remove that for now. We'll copy this down 4 times because now we're going to need to modify them. So this will render the first tile. So if we run this, you'll see the first tile. But now we need to make this X one go over 1. So what we're going to do here is we are going to X offset. I think that should just be X offset because it starts in the middle. Here, the Y offset is still going to be Y offset because it's on the same plane as this one. The X tile plus Y tile times 32, we're just going to need to add 1 here, so we'll just put it in here, just because it's going over 1 tile. And color's the same. The next one is 1 down under that tile, so it's going to be the same as here for the X, but the Y is going to be different this time. Oh wait, I didn't need to copy that. But the Y is going to be different, so the Y is going to need to be plus modifier, because now we're moving down. X tile plus Y tile, and this is going to need to be Y tile plus 1 here. Okay, we'll actually put this in brackets as well, just so that we know that the X tile plus 1, the Y tile plus 1. And then this one is going to be modified on both of them. So this one is just going to need to be, it's going to need to be that, just because we need the center, so it's the X offset. And the Y offset, this same Y offset as this one, because we're on the same plane as this. These are the 2 lower halves here. This is the upper body, this is the lower body, okay? Just if you didn't get that. The Y tile here is going to be plus 1, and the X tile here is also going to be plus 1. Because now we've moved over 1 in all quadrants. So there's that. And that should render them out okay. We'll check that in a minute. Now we're going to do the collision detection here. Now this isn't going to be this is very, very basic. We're not going to do anything. We're just going to make sure he stays on the screen. Actually, you know what? No. We'll do that next episode. We'll deal with collision next episode. So don't worry about that for now. Next up, we need to add our player to the game. So we're going to go into the game class here, and we're going to go all the way to the top, and we're going to add a new global variable here. Public player. You could add this in the level class, but we want this player to be constant and to be able to go through different levels, so we're going to keep him up here. Is that not importing? Okay, I guess that was importing. I'm not sure why that was showing up like that. Shouldn't have been. And then here we're going to do player equals new player. And what did player take? Let's just copy what he has. Yoop. Just so I can see it. So we got level. We got X and Y, so we'll start them at 0, 0. And we got input. Okay, so that adds him. Next we'll need to do a level.add entity and player. We don't have this yet. We'll make that right now. And do we have level.tick and all that kind of thing? Level.tick, yep. And this, instead of just X, it'll be player.x and player.y. Yeah. Okay, so now let's go into the, what are you doing here? Oh, yes, level. Okay, so let's go into the level class, and we're going to need to add that add entity. So to add an entity, first we need to have a list of entities. So we're going to make a public list here of type entity. Entities equals new array list entity. I spelled that wrong. En. No, I didn't. We're going to import it. Just import the default ones. It should come up correctly. Which it looks like it hasn't. Why has that not come up? What type is list? It's probably incorrect, isn't it? Oh yeah, that's the Java. That's incorrect. List needs to be java.util.list, that one. So import all that, and everything goes away. Now we go down here, and we go public void add entity. So we create that function, and it accepts an entity. Okay. And in this function, all we're going to do is this dot entities dot add entity. Okay, so that just puts the entity in this thing. And now what we need to do is whenever this level's rendered, we need to render the entities. So we're going to say entities for entity, and we'll just call it E, entities. What this is here, what I'm doing right now, it's a kind of expedited for loop. So instead of doing for int I is equal to this, yada yada yada, you can just loop through all the variables and take every variable from that. If you don't actually need an index variable, you can do it like this. I'm just going to say e.tick. Because that tick function, again, is back in the entity class here. So we can call that function. We can say, we know it's there, so it's good. I'm going to copy this down now, because in render tiles, we're probably going to need a render function. No, let's make a render entities function. Screw it. So we're going to go here, we're going to go public void render entities, just so we can render the entities on top of the actual, whatchamacallit, like if we don't want to render them under the tiles, we want to render them on the tiles, or if there's some sort of thing that we want on top, we want the entities to be specific location. So then we're going to say here entities.render and screen. That's all you need there. Okay, that should be that. If we go back into the game now, we need to call that render function. So we're going to go down here. We'll go to this render function. Now this is what I was saying right here. Now we have level.render tiles, and we have, this is for the fonts at the top. So we want to render the entities after the fonts. So we're going to say level.render entities screen right there, just so we can see them after the fonts. Now if we've done everything correctly, which I think we have, we can run this and see what happens. So let's run this up. We should see a little guy pop up. Anytime now. There we go. Okay, so we have him, but he seems to be backwards. Now, why is he backwards? Let's go debug this. So we do have a player now, and you can see he's moving around. Okay, he's moving with the board. But let's find out why he's flipped like that. So let's go back into the player class. I'm actually going to drag this over here. Actually, no, I won't, because then you guys can't see as much. Sorry about that. Let's go down and look here. So we got the left side. Oh, that's why. This modifier should not be here. This modifier should be on the second one, not the first one. What that essentially was doing was it was adding that extra pixels. This puts us at the very beginning, so it puts us wherever the player's location is. It takes you from here and it moves you over here essentially, and it moves it down 4 pixels here, so your center's like there, but your actual center's there. And then we got to move it this way and this way, so it was flipping those. I'll explain that better if you need me to, but we're gonna spice up this render function next episodes. So don't really, or not next episode, next upcoming episodes. So don't worry about that too much. But yeah, it should be working fine now. So we're gonna run this again and see what's going on. There we go. So there is our entity guy. You'll see that my frames are running a little slower because I'm recording as well right now. But yeah, that's been this tutorial. I think that's really everything I have to say for this. You can move around with your guy now. You'll see that he won't stop at the edges. If I go over and over and over and over, he won't stop. He just continues to go. And if he goes up, he'll just go up. So that's not done yet, but the basic layout of this is. And actually, I'm seeing a bug here. If we hold right and we hold down, you're going faster on the X. So let's fix that really quick. Should be something around here. If you're going down, minus, up, move XA, YA. Okay. Let's check the mob class. Okay. XA, YA, XA, YA, 0, 0. Oh, I see what. It's right here. You'll see that we have YA on the X. We shouldn't be having that. That should be at 0 here. And this should be YA. Because that was not the correct place. That was the issue with that. So let's run it again. And let's see if that fixes it. It should fix it, though. Move down, move sideways. We're all good. So now he's moving around. The colors seem to be alright. I don't know if... I like this kind of tealy color. I'd like it to be a little bit more green, but that's okay. We might make him a little bit more brown instead of just black hair and stuff like that. But there's that. Hope you guys enjoyed this lesson. And take care, guys. I will see you guys next time. Next time we should be doing some... So I'll probably record it right after this. I'll think about it for a little bit and then record it. We'll do some stuff with actually making him move. We'll probably do walking animations next. So I will see you guys next episode, and have a great day, guys.